So we started off with inferential statistics. Inferential statistics, apart from descriptive statistics, it concludes it those includes the conclusions or inferences from sample data about the population parameter. And we started off with the definition for hypothesis. So hypothesis is nothing but the proposed explanations for a phenomena that has not yet been proven. And then we saw what are the methodologies of hypothesis testing. Started off with null hypothesis, which is the initial assumption or belief, and then comes the alternate hypothesis, which is just the opposite of null hypothesis. And the third case is experiments, which basically consist of statistical experiments or analysis. And then we have the fourth step in the methodology, which is the step where we accept or reject null hypothesis. I guess till now it's clear. We will see, these steps will be more clear when we do some problems. It's not much complicated. So maybe let's consider a very small example. So let's consider an example where colleges at a district A has an average passed percentage of students, which is 85 percentage. So let's say we have a district A, and then we are considering colleges in that particular district, and the pass percentage is pass percentage in that particular district is nothing but 85 percentage. And a new college is opened in the same district, and it was found that the sample of students of 100 is taken from the new sample or a new population. So now the new population has one more college in apart from the colleges which we consider for the earlier case where we saw the pass percentage is 85 percentage. Now a new college is adding to the colleges, so maybe it's a new population, and then we are drawing a sample of 100 students from that particular population, and then we found that pass percentage has changed to new pass percentage is nothing but 90 percentage. So this is a case, and it also says that the standard deviation here is 4 percentage. This is the population standard deviation, sigma. And here if we have to propose a null hypothesis, what will be the case? So we are given information about the pass percentage, and we are when we are making a calculation with the new sample taken from the population, we are getting a change in pass percentage. So the null hypothesis which we state here will be that pass percentage is pass percentage is 85%. So as I said, this is the initial belief. So the information which we had at the initial stage. So we will be sticking that as we will be sticking with the same information as the null hypothesis, and anything which is opposite to null hypothesis. So here we saw that the pass percentage is getting changed to 90 when we are adding a new college and we are drawing a new sample from the population. So the alternate hypothesis we'll say that pass percentage is not 85 percentage. Simple. It's just like that. Whatever belief we are taking as null hypothesis, the opposite will be taken as alternate hypothesis. Then the main parameter or the main term which we have to consider is p-value. P-value is nothing but a number which is calculated from statistical test that describes how likely you are to have found a particular set of observations if the null hypothesis were true. So p-value is a quantity which we often take into account when we are doing this hypothesis testing to test whether the null hypothesis is true or false. That means that if we have to if, like for example um, let's consider a case of keyboard where um, okay, maybe we are taking this as this we are taking this as the no, just no, this is much complicated, we don't have to go to that. Yeah. Okay, so let's consider a case where we have a particular distribution and it says that we will be getting a mean value with 95% confidence, that which says that we have a mean value which is falling somewhere here, and with 95% confidence we can say that yeah, this particular value x is falling in this particular area, and it says that it is 95% confidence interval. Then anything which is below, less than or more greater than this area, so it will be, if it is a symmetrically distributed part, then it will be this part will be having 2.5%, and this part again will be having 2.5%. So if we are sure if the particular value falls in this particular 95% confidence interval, then the p-value should be less than this quantity, this particular quantity over here, which is called significance value. And if the other thing is happening, then we can reject the null hypothesis. Maybe we can look for a very simple example. Let's consider coin tossing experiment. In the coin tossing experiment, we don't know whether the coin is fair or not. So we have to check if the coin is fair or not. In that particular case, if we are, let's say, tossing the coin for 100 times, and the probability of head and probability of tail can take any value between 0 and 1, right? So let's say it can take 0.5, 0.5, maybe it can take 0.7, 0.3 or so. Like it can take any value between 0 and 1. And we are considering a null hypothesis here, which is that the coin is fair. And what will be our alternate hypothesis? Just the opposite, which says that coin is not fair. And if we are tossing the coin for 100 number of times, and let's say we are getting a distribution something like this. So we are considering the case that with 95 percentage confidence or confidence interval, the coin is fair. With 95 percentage, this confidence interval also we can fix, we can initialize that value. If it is not given the question or if it is not specified, we can start off with the confidence interval and then solve and check the case and then like if you can fix it as 95 percentage, 80 percentage, like according to the according to the problem which you're dealing with, you can initialize the value. Here for just for example, I am taking the confidence interval as 95 percentage, and I am assuming that the coin is fair with 95 percentage confidence. So fair means like most of the cases I should be getting the value zero point 0.5, like the probability value should be 0 0.5, 0.5, right? And as I said, I considered this particular area within that 95 percentage confidence, and this area over here, this area over here is my, those two areas are my rejection areas. So where I reject the fact that it is, the coin is fair. So these two areas are my rejection areas, rejection area, and this is also my rejection area. And the part which is shaded in yellow is my acceptance area. So here we are assuming that with 95 percentage confidence that the coin is fair, and we have two tails over here for rejection, right? So that two parts I am taking, those two parts are having equal area, and so since the 95 percentage goes under this yellow shaded area, so here and here I will be having 2.5%, 2.5 percentage. So this for this area, the value or the significance value, I can take it as 0.025, and here also I can take it as 0.025. So the significance value over here is always denoted as alpha, which is equal to 0.05. So over here 0.05, how did that come? So it is nothing but 1 minus 0.95. 95 because we are taking the confidence interval as 95 percentage. So this is how this significance value is calculated. And we were discussing about p-value, how p-value is taken for null to say that whether we should reject or accept the null hypothesis, right? So that was our question. Uh, yeah. Is there any question?
Yes, Adhira.
Yeah.
So, as you have written, significance value has some meaning, like
Mhm.
you have written some mathematical interpretation for it.
Yeah.
So, in similar way, do we have any mathematical interpretation for p value as well?
Yes, yes. Yeah, that's what we are I mean, going to discuss. Like as I said, the significance value is calculated as nothing but one minus the confidence interval value. That is, here we are taking as 95 percentage for, so we will be calculating it as 1 minus 0.095. Similarly, this p value, it is not a universal value which we treat for p value and significance value. With according to the problem and according to our initial belief which we are taking, it changes. And for each problem, according to how we are starting with the null hypothesis and the confidence interval, the p and the significance value will change. And we will see what the significance of p value is and how p value is made used to calculate or say whether we should accept or reject a null hypothesis in the next session now itself. Yeah.
Okay. Okay. Thank you. Thank you.
Yeah. So if p value is less than the significance value, we should reject the null hypothesis. And if the case is else, we should accept the null hypothesis. For most of the statistical test, we will find a clause where it says that it is less than the significance value is less than p value, and we will be always seeing p value everywhere where we are doing the statistical test. So it depends upon the test which we are looking into, and it also depends upon the initial belief which we are taking into account. Here, since we took it as 95 percentage confidence interval, the alpha value or the significance value will be a 0.05. So if a p value is less than significance value, so in this case, if p value is less than 0.05, we will reject the null hypothesis which says that the coin is not fair. And if the p value is greater than 0.05, we will accept the null hypothesis which says that the coin is fair. So this is how the whole methodology of hypothesis testing is. But we will see into detail how this is done for each particular hypothesis testing. Yeah, so now we discussed about the methodology, starting off with null hypothesis. Then we will consider the opposite of null hypothesis as alternative hypothesis. And then we considered, we saw that the third step is to conduct statistical analysis or test. And then the fourth one was to say whether we should accept or reject the null hypothesis. And how we are doing that? We are doing that by checking if the p value is less than or greater than the significance value. These were the steps which we saw. So now we will be seeing in detail how this hypothesis testing is done in each different case. So the hypothesis testing, for this section we will be mainly concentrating on four types of test: Z test, T test, chi-square test, and then ANOVA test. Okay. So, what maybe for today we will try to cover at least the first two, and then in the next session we will cover the chi-square and ANOVA test. So the Z test and T test is basically used where we are considering data which have the averaged data. So there are many cases where we are making use of averaged data, and in all those particular cases, Z test will be used. Do we have any question?
Uh, yes,
Mm.
sorry, I think
Yeah.
maybe it's the same question as what Poonam asked.
Mhm.
I mean, or maybe I missed when you explained how do we arrive at the p-value? I mean, you explained how we assume what the significance value is based on the confidence interval,
Mm.
but how do we arrive at the p-value? And like I think once like how.
Yeah. Yeah, I understand the confusion there. Yeah, I didn't say how we are calculating the p-value yet. Yeah, that
Okay, okay,
it is
fine.
completely mathematical, and we will see that in detail how exactly we are
Oh,
calculating.
okay, okay, yeah,
Yeah,
thank you.
yeah, it's okay. So,
Poonam
so
also has a question, I guess. Or
sorry.
Poonam's hand is also raised. I don't know.
Hi Poonam, do you have any question?
I think it was raised earlier.
Yeah,
Maybe.
maybe. Mhm. Yeah. So Z test and T test, as I said, basically they will be dealing with data which are averaged data. So first we will see in detail what Z test is. We saw how to calculate Z score and all earlier. So Z test. So we have to consider the conditions first for calculating or doing an Z test. For in order to conduct an Z test, the initial condition is that the population standard deviation sigma should be known. And the second condition is n, which is the sample size, should be greater than or equal to 30. So these are the minimum conditions which are required to do a Z test. So let's do an example. So we will be more clear about how to calculate the p-value and how to check if null hypothesis stays or should we reject and all those. So let's consider an example. The example says that the average height of all residents in a city is 168. So it says that the average height is 168 centimeter, and with a standard deviation of 3.9. A doctor believes the mean to be different. He measured the height of 36 individuals. So a doctor is conducting a test with a sample size of 36 and found the average height to be 169.5 centimeter. And the question we are asked is if at a confidence interval of 95%, is there enough evidence to reject the null hypothesis? So according to the question, what will be the null hypothesis? The null hypothesis will be the fact that the mean height is 168 centimeter. So here the question is at 95% confidence interval, is there enough evidence to reject the null hypothesis? So we will go according to the system which we followed earlier, starting off with first one, which is null hypothesis. So null hypothesis states nothing but the average height is 168 centimeter. And B, we are going to the alternate hypothesis, which says that the average height is not 168 centimeter. And then C is the case where we have to do the experiments, right? So we have population mean, then we have population standard deviation also, which is 3.9. We have sample size, which is n, which was 36. And then we also had the sample mean, which is 169.5 centimeter, right? These were the parameters which were given. Okay, so here the question itself, it was specified that the confidence interval is 95%. And since the confidence interval is 95%, alpha or significance value will be nothing but 0.05. So as I said, it is nothing but 1 minus confidence interval. So here this will be a two-tailed test. So two-tailed test is nothing but we will be having rejection area in both sides, in the positive end and in the negative end, because it is not saying that this mean value is less than 169 centimeter 168 centimeter or greater than 168 centimeters. Just say that it is not equal to 168 centimeter. That was our alternate hypothesis, right? So we will be having rejection area in both ends, and this is our 95% confidence interval, and which says that the mean value is 168 centimeter, and here it's 0.025, and here also it's 0.025. This 0.025, it comes by dividing the significance value, or 0.05 divided by 2, because that is equally partitioned into the two tails of this hypothesis test. So the Z score from the experiment which we designed over here, this is the experiment which we maybe this particular thing, this particular graph here is the experiment which we designed according to our belief and according to the given parameters. According to the designed experiment, the Z score is nothing but 1 minus 0.025, because this 0.025, this is 0.025, and this particular area will be having 2.5 percentage. This particular area will be having 2.5 percentage with 2.5 percentage confidence, we can reject our initial belief in this particular area, and in this particular area also we can reject, right? So our Z value is 1 minus 0.025, which is equal to 0.9750. And in order to check the area for this particular value, we have to look into the Z table. So that is available in internet, the Z table. If you look into, you can see Z table, T table, chi-square table, F table. Like for all hypothesis test, we will be having, we have to look into tables to check the area. So here the area, if you look into, that will be coming it as plus 0.96. And similarly, I know this part will be little confusing because we have to check the table over here. Let me check if I can share that. Or else I will, after the class, I will send the Z and T table links in the in our group, so you can look into that, because each table, how to read that and everything is little different. Just to now I'm just trying to make the clear steps clear, how to calculate the p value, because if we are going into the like table individually, then it will be taking so much time. So yeah, just understand that there is a Z table particularly for Z test, and we have to check the Z score to get the area for that particular value. And since the Z score value is 0.975 here, and the particular value which is corresponding to that value is 1.96, since we are having a two-tailed test which is symmetrical in both the ends, since we got 1.96 positive value in the one positive end, we have to take the similar minus 1.96 in the negative end as well. So now maybe if we redraw, so this particular, maybe here we can write this particular value is corresponding to minus 1.96, and this particular value is corresponding to 0.96. And here we also already saw how we have to reject and accept the null hypothesis, right? So if the z is less than, if the z score which we are calculating from the data which we had, if the z score is less than minus 1.96 or z score is greater than 1.96, we should reject. So z score less than 1.96 and greater than 1.96 means that this is the less than 1 minus 1.96 area, this particular area, and similarly greater than 1.96 area, this is the area. So those two are our rejection areas. And the z value for this particular test will be calculated as, we saw the formula earlier. The z value is sample mean minus population mean divided by population standard deviation divided by root of sample size. So here, yes.
So I was having a small doubt regarding this Z score and uh, Z value. So first, initially we calculated the Z score, right?
Yeah.
So how?
Yeah.
Okay. So I was thinking both are like same. So how they are
Actually,
different?
the confusion, I understand that, because initially I said the z value. So z value, z score, it's same only, but then the z value which we considered earlier here, when we started off here we calculated the z score, right? This particular score was calculated by the experiment which we designed, which says that 2.5 percentage here in the left and the 2.5 percentage in the right, we are going to reject. So that is how we calculated this particular z score. And this is from the experiment, and we are trying to capture that particular area from the set table. Hmm? And then the next one here, which we are going to do the Z test by looking to the data which we have. So this particular one we will be calculating with the data which we have in hand. Because here also we are trying to calculate the set score itself, but then we are making use of the data which we have in hand. So here the Z score will be calculated as hi. Any doubts?
Yes, like the question is for the Z score you took. I mean, you calculated it as 1 minus 0.025.
Mm-hmm.
So you have taken the rejection area only on one side of the tail, one tail. Why not both? I mean, I don't know. Is it?
Yeah, the doubt is completely understandable. Yes, I didn't say that point because yeah, I forgot to mention that point because we have particularly z values calculated for two-tailed and one-tailed test. So in this case we are dealing with the case where we are having a two-tailed test, right?
Okay.
So two-tailed
Okay.
test with the value z value which is calculating with the rejection probability in one side as 2.5 percentage.
Okay.
Yeah, so
Okay, thank
if we are looking into the z table and checking the area, we will be having option where we are doing whether we are doing a one tailed test or a two tailed test. So you are yeah, I should have mentioned that earlier. Since we are doing a two tailed test, when we calculate the z value, we will be checking the area for a two tailed test with z value corresponding to 0.025. We will be getting one value. We will be getting a one particular value as area. Here for example it is 1.96. Similarly, if you are going for a one tailed test, I will just show how a one tailed test will be looking like. So if we are looking for a one tailed test, it will be only having one rejection area, like only this particular area or the other side, one particular
Yes.
area will be rejection. So here the area which we get with 95 percentage confidence interval will be entirely different. I mean, I will
Okay,
send the
understood.
link
Thank you.
of how to calculate the Z value later on. And you can also look into some, if you just check Z value, T value, or Z table, you will get a big table. Then we have to, I think, once as we did our log value calculations and all during our 12th
Yeah.
exams, similarly, we have to check which value is corresponding to a particular Z value. Similar calculation.
Okay, understood. Yeah, thanks.
Yeah.
Thanks.
So, as I said here, the Z value is calculated as the sample mean minus population mean divided by population standard deviation divided by root of sample sample size. So this particular value is corresponding to 169.5 minus 168 divided by 3.9, which is the population standard deviation, divided by sample size, root of sample size, which is root 36, and it is corresponding to 2.31. So this is the Z score which we calculated, and this Z score 2.31 is greater than 1.96, right? So that was our earlier that was our condition over here. If the Z value is less than 1.96, less than minus 1.96, or greater than 1.96, we should reject, right? Here we are getting the Z value as greater than 1.96, which means that we should reject. So we should reject the null hypothesis, and here the p-value was, here the p-value is less than 0.05 because we are going to reject, right? So we are we got the conclusion that p-value is less than 0.05. And if we go again into the Z table, so the calculation is very tricky, and it is little bit complex, I understand that. So if we go back into the Z table, we understood that 2.31 is the particular Z value which we got from the data which we had in hand. So this particular side we are taking it as minus 2.31, and this side we are taking it as 2.31. And here if we are looking into this particular value in the Z table, the value here comes it as 0.01044. So this is the area corresponding to 2.31 minus or plus 2.31 for a two-tailed test. And similarly, since we have this particular value in one side, we will be having similar area in the right side as well. And the range, the acceptance range, will be having the area 1 minus 2 into the area which we had in both sides, right? So this area will be 0.9719112. So p value here is 0.101044 plus 0.01044, which is equal to 0.02088. And here p is less than 0.05, so which again says that we have to reject the null hypothesis. I know this is very confusing. Yeah, you can ask the doubts now. I think we should clear the doubts, then move forward. Otherwise, it will be very complicated in the next case. Are there any doubts or confusions?
So initially we found that plus 1.96 and minus 1.96, right?
Yes. Yes.
So that was for what was that value? That was like the Z score or p value.
Yeah.
So what?
That was not p-value. That 1.96 and minus 1.96 we calculated for the confidence interval which we had in our initial belief, that was 95% confidence interval, and which and we also said that we are having a two-tailed test. So with two-tailed test we had like 2.5 percentage in the right side and 2.5 percentage in the left side, right? So here if you so here this 0.25 0.025 and 0.025, and if we look into 0.025 for a two-tailed test, that particular Z was corresponding to area or a score of 1.96. So since we are having
So what is that called? Is it called Z score or
that particular
what?
one is called an area. Basically it's called an area. 1.96 is called area for that particular Z score. And then since we are having a symmetrical distribution on both sides, we are taking the negative of that value in the other side. And with that value, we started with our calculation. And we said that if this particular, for null hypothesis to stand, it should be between this area. This green area is our acceptance area. So it should be between minus 1.96 and plus 1.96. And if it is going beyond or less than that particular value, like minus 1.96, less than that value, and greater than 1.96, we should reject. And when we calculated the z value with the data which we had in hand, this calculation was done with the data which we had in hand, right? So if we do that calculation, we got the z value as 2.31, and this 2.31 is of course greater than 1.96. So we already got an idea that we should reject, right? But we haven't calculated the p value yet. So our next step was to calculate the p value.
Okay, can't we just stop here and reject the
Yeah,
null hypothesis?
we can do that, because from here itself it is clear that the null hypothesis doesn't stand, and we have to reject it. It is clear from this stage itself, but just to make the picture more clear, to make a correct value for a p value for more significance test, or for more statistical test, then for that we are looking for the correct p value for this particular experiment. For that, what we did was, initially we had such a distribution, but then the value here for the with the belief which we had was 1.96 and minus 1.96, right? Minus 1.96 and 1.96, with the belief which we had, like with the 95% confidence interval and a two-tailed test. But then after the calculation of the z value with the data which we had, we calculated this particular value as minus 2.31 and 2.31. This value calculation is okay, right? 2.31 here. Okay.
Yeah, that is on the table now.
No. 2.31 is calculated from the
Okay, yeah.
data. And then we have to look again into the table for this 2.31. 2.31 in the table is corresponding to a area of 0.98956. And this 0.98956, if we do this particular area, 1 minus 0.98956 is nothing but 0.01044, like the each areas in the rejection side. So from this we got how much area, or earlier it was 2.5 percentage. Now it just come to 0.1 percentage. 0.1 percentage. Sorry, 1 percentage. 1.04 percentage in both sides. So then now we have this particular value in both sides, and we know that the acceptance area will be nothing but 1 minus 2 times that rejection area, right? Like this tail and this tail, and we got this area as 0.97912. And next step is to do the p-value calculation. P-value calculation is similar as we did earlier. Earlier for 95% p-value was 1 minus 0.95. Here it will be 1 minus 1 minus 0.97912. So it is nothing but 2 times 0.01044. So it is 0.02088, and the value is less than 0.05. So we reject the null hypothesis. So it is just stating the above statement which we had.
Okay, got it. But it's a bit confusing,
Yeah, yeah.
even though I have read about it and watched few lectures, but still it's
Yeah, yeah, I
complicated.
understand. For me as well, it is confusing every time I look back into this. But maybe we can do more problems or discussion with the similar questions, and maybe the idea will be more clear. And one thing which basically I have to say is that, yeah, like we don't have to do this calculation manually. Um, I, I think at any point of time the manual calculation won't be needed, so we just have to understand the idea how this p value is calculated, how like for a particular, like for example, let's say we have a time series data, so it's changing in every point of time, and we are checking the stationarity. For example, stationarity means nothing but the statistical quantities are staying in a stationary value. Hmm? So that is also a stationarity test which we mostly do for time series data. So most of the time series data, it won't be stationary. The data will be the mean and variance, every parameter will be changing at most of the points. So if we do the stationarity test, and we will be just saying that okay, the p value is less than, like if we do the statistical test with the programming, it just gives us the output, yeah, the p value is less than this significance value, so the data is non-stationary. But we just have to understand how this p value is calculated, what exactly that is. We just have to understand those terms, and we have to understand what is going inside, and how the calculations are going on. Other than that, we don't have to do this manually at any point of time. I don't think that this is we don't have to um, understand the calculation step by step, but we just have to understand the terms, what is significance value, what is p value, what is confidence interval. And we just have to also keep in mind that for each statistical test, z test, t test, the coming test like chi-square and ANOVA, every test has different tables. So we have to the computer is doing calculation by referring into that particular table, and yeah, that's how it is happening. All those things we have to keep in mind. And as I said, for z test alone, sorry, for z test and t test, we are looking into data which are mostly averaged data. We didn't look into t test, but we will look into that maybe in the next session. Otherwise, I guess it will be very confusing. I, I think this itself is already confusing. um, yeah, like if you have any questions, I do understand that it was very complex. You can ask, or if any questions come later into mind, you can just post in our group. I'll try to answer. And if you find more examples which are related to the hypothesis testing, we can solve that later in our sessions. Yeah, I think we should conclude for today.